All right, so what we got going? Systems of quadratic equations. All right. So the most important thing that you need to know about the solution, or really this entire unit, um, I would argue the most important thing is what the solution represents, and that is where these functions intersect. All right. So what we're doing, we're not just finding random points; we're finding the only points where these two functions share. Right. And we looked at the possibilities of two solutions, one solution, or no solutions, right? So let's look here. We got a system of quadratic equations. Well, the top one's quadratic. The bottom one is certainly linear, and we need to solve these algebraically, right? So that means crunching numbers. Um, let's go with the substitution method, right? You could use either elimination or substitution. It's really personal preference. Right? But you see the top one's already solved for y. The quadratic's already solved for y. The linear function, we need to solve for y before we can set them equal to each other, right? So in this bottom equation, we're just going to subtract x from both sides and then set them equal to each other. All right, not too bad. So what do we have on the for the quadratic? We have x squared plus 3x minus 7. And then our linear, right? Remember we subtracted x from both sides, giving us y equals negative 2 minus x. So where do these two functions intersect? That's what we're trying to find out. Okay, because the when you look talking about functions, the exponents really dominate the show. So you can see this exponent of 2 here is the highest one on the board. So because this is a quadratic, we got to set it equal to 0, right? So let's simply add 2 to both sides and add x to both sides, right? So now I have oops, x squared. Right, I'm adding x to both sides, so now it's plus 4x. I'm just combining my like terms on, and then subtracting 2, adding 2 to both sides, right? So now we have a minus 5 equals 0. All right, perfect. Now that it's set equal to 0, you might notice that this one does factor quite nicely, right? With 5 being a prime number, it kind of makes the options pretty limited on how this could factor. So, it's just 5 and 1, right? Well, how could the product be negative and the sum be positive 4? Well, that would only be the case if the 5 were positive and the 1 were negative, right? So we'll draw our double bubble, our product of two binomials. We have the quantity of x plus 5 times the quantity of x minus 1, right, equals 0. Right? If you ever doubt if you factored correctly, just FOIL it out. FOIL it out, and you'll get this quadratic back if you did it correctly. So that's how you know. Okay. So now that both these binomials we're going to set equal to 0. Okay. So x plus 5 equals 0. Oopsies. And x minus 1 equals 0. Okay. So subtracting 5 from both sides, one of my solutions is x equals negative 5. Make that minus sign a little bit more obvious. And then over here, we're going to add 1 to both sides. My other solution being x equals positive 1. Right? Now, these are the two x values. Be very, very careful. I see students all the time who want to write down this coordinate point. Okay? That's not it. That's not what's going on. This is two halves of two different coordinate points, right? These are the x values. Now, we got to find out when x equals negative 5, what's the value of y? Right? And since the two functions, um, we're finding where they intersect, the y value is going to be the same, right? Meaning I can plug it into either equation, right? So my first solution was x equals negative 5, right? So if I plug that in right here, and I say y equals negative 5 squared, or was it? It's not reading very well. plus 3 times negative 5 minus 7. Okay, so you got your negative 5 squared. Righty, positive 25 minus 15, right, minus 7. 25 minus 15, right? So we got 10 minus 7. So when x equals negative 5, right, then y equals um, 10 minus 3. Sorry, 10 minus 7, all right, which is 3. Okay, all right, so that's one solution. And the other solution being x plus y equals negative 3. All right, if I plug in negative 5 here, x for negative 5, let me go ahead and back up. Suppose I would have put it in here, right, which would have been easier, but like I said, it won't matter. So when x equals negative 5, add 2 to both sides to solve for y, right? Y equals 3. So in any event, we know these two functions share the coordinate points, so that's one answer. When x is negative 5, then y equals 3, right? Yeah. Okay, so that's one intersection. Okay, so now I have this x equals 1 here. So let's put that in, right? So we know the other solution to be x equals 1. Right? When x equals 1, if I plug it into this equation, I get what? Y equals 1 squared plus 3 times 1 minus 7. 1 squared is 1, plus 3 is 4. All right, minus 7 is negative 3. Okay, or you can see we plug it in here too. If I say x is negative, or sorry, positive 1 plus y equals negative 2, subtracting 1 from both sides. Either way, we get y to be negative 3, right? So it won't matter which one you plug it into because they intersect. So we know when x is 1, the other intersection is 1, negative 3. When x is 1, y is negative 3. Okay, so this is the answer. These two locations, that's where these two functions intersect, right? And I always think the illustration is helpful. Let's go up here. Right? And let's just get rid of this. Okay. So here's the graph, courtesy of Desmos. Right? Just plug in these two functions. You can see where they intersect, the parabola and the linear function, negative 5, 3, and 1, negative 3. Right? So however you solve it, the solutions represent where these intersect. The only points they share, right? Possibility of 2, 1, or 0. They may never intersect at all. Right? Okay. Bow, bow, bow. So let's go ahead and clear the board. We got another system here. This time they're both quadratic. You can see they're both quadratic. Um, get some workspace. Do, do, do. Okay, but it's going to be the same idea. All right, we're going to set them both equal to each other. If we're using the substitution method. Use elimination too. All right, be careful now. Use elimination. It's really personal preference, right? And depending on what would be easier, right? The functions you're given would really dictate what would be easier, right? Um, Actually, let's go ahead and use illumination on this. That's probably a good idea. All right, do you notice that since mm, that would eliminate x, we could eliminate y if we subtracted them. Right? I think it would be easier since they already saw for y. Actually, it's probably just going to use substitution. It won't matter. It really won't. Let's see if we can go with a different color. Feeling this one. It's a good looking color. All right. So you can see they already solved for y for us. All right. So that first step is done. Let's just go ahead now and set them equal to each other. Okay. So I know that x squared plus 18x plus 35. Oh, my stylus is giving me a hard time. Plus 35 equals negative x squared plus 2x plus 5. Okay. Because this is quadratics, we're in quadratic world, so we have to set this equal to 0. Let's go ahead and do that. Let's put this guy's front and center. Okay. Um, so I'm just going to take everything on the left, move it, everything on the right, move it to the left. So I'm going to add x squared to both sides. There we go. Okay, now I'm going to subtract 2x from both sides. So 18x minus 2x gives me plus 16x. Okay, and then my constant. At list 5, I want to subtract 5 from both sides. Let's go ahead and write plus 30 here. Now it's set equal to 0. Okay, and one optional step. You notice that A, B, and C are all even. So, all right, so because they're even, let's go ahead and divide by 2. It'll make our life easier. Okay, so dividing A, B, C, and even 0 technically would get divided by 2. All right, but that gives us x squared plus 8x plus 15 equals 0. Okay, this one actually factors quite nicely too. All right, so two numbers that multiply to 15, and at the same time they have to add 8. All right, so kind of play around with that until you figure it out. You know, the thing about factoring is it doesn't always work. This one is quite beautiful. It factors quite nicely, right? We'll factor it. Like, oh, I noticed that 5 and 3, they add to 8, and they multiply to 15, right? If they're both positive, it'll factor just like this. Okay, and the product of two binomials here using our zero product property. Um, let's set them both equal to 0. So if x plus 5, oopsies, x plus 5, if that equals 0, right, then that means x equals negative 5. Okay, and then x plus 3, that equals 0, x equals negative 3. Okay, this right here is not the coordinate point. It's not the solution. Okay, please don't do that. Please don't fall for that common misconception. What you have to do now is take each of these one at a time. Right, start with the negative 3, I guess. Right, it doesn't matter. All right, and plug it back into the equation and solve for y. Right. Okay. So. You see here, I already did it here for the sake of time. All right, I plugged in the negative 3. All right, and you see no matter which equation you plug it into, we'll get y equals negative 10. So one point that these two functions share would be negative 3 and negative 10. Right, so that's pretty cool. All right, the other solution was x equals negative 5. All right, so you plug that in, right, to both of these. Realistically, you would only have to do one, but it's nice just to double check, okay, because mistakes. None of us are above silly mistakes, right? Especially when we're tired. Especially when we're tired. All right, you can see here, no matter which one I plug it into, I get when x is negative 5, y is negative 30. All right, so that would be the last point they share. Let's go ahead and take a look at the graph here. Courtesy of Desmos, plugging in, these two parabolas intersect right here. Yeah, um, that about covers it. Very, very cool topic. Thank you so